Hello students, I'm Dr. Seema Singh and you're watching me on my channel Bonding with Chemistry. In the last class we started with first chapter of class 12, that is solutions, wherein we studied what is a solution, what are the different components of a solution and what are different types of solution. I also took up NCERT exercise questions from the same topic. In today's class we are going to study about the different ways of expressing concentration of a solution. So without wasting time, go grab your materials and come study with me and learn with me. Let's get started. My dear learners, I told you a short while ago that these are the topics that we completed in my last video, whose link you can see on the top of this video. Well, if you have missed this class or you want to go through these topics again, you can always visit the link that is provided on top of this video, right? And it's also provided in the description box below. In today's class, we'll talk about expressing concentration of solutions. Now, I've mentioned in my last class that this topic is important for numerical point of view. You have plenty of formulas here, and these formulas will be used to solve other numericals based on the other topics also. So this topic is important from numerical point of view. I want you to keep a rough copy and a pencil or pen handy with you so that you can do calculations with me. Now, let's begin with this topic by understanding what do you mean by expressing concentration of solutions, right? If I have to equate this concentration, let me say this concentration is similar to knowing composition of a solution, right? Composition of a solution. Now, if this composition seems to be a difficult word, we'll break it further. Composition means components that we did in our last class. There are two components of a solution, namely your solute and solvent, right? So composition means how much amount of solute or solvent or both are present in a solution. You want to know what is the composition of a solution. Solution is made up of a solvent and solute, right? Now you want to find out how much solute or solvent is present in a solution. That is called composition, and that is what we call as concentration of a solution. My dear learners, actually there are two ways in which we can express the concentration of a solution, right? One way is called as qualitative and the other is called quantitative. What we are going to study in today's class is quantitative way of expressing concentration. Now, to understand the term qualitative, what does it mean? You must have seen in your laboratories, in chemistry laboratory, your reagent bottles where chemicals are stored. They must have been marked as dilute HCl or dilute sulfuric acid and concentrated HCl. The teacher tells you the dilute HCl has less of acid and more of water, whereas concentrated has more of acid and less of water and it is more dangerous, right? So what does it mean, dilute and concentrated? It tells you about that, okay, this has less acid and more water, whereas this one has more acid and less water. It's only telling about that in one you have more of solute and in other you have less of solute, but how much more or how much less, the quantitative explanation is not told, right? And we are interested in knowing how much solute or how much solvent is present in a solution, right? It is similar to like you are drinking an orange squash and suddenly you say no, the flavor is not coming nicely, and you go and add more of orange squash, stir it well and then drink, and you say now the flavor of orange is coming properly, or you're finding it more tastier. Why? You will say the previous one was dilute, now this one is concentrated because now it has more of orange squash as compared to the previous one. So what happens is qualitative adds to sometimes confusion. Why? Let me give an example. Let's take the example of same orange squash. You have 3 glasses, similar glasses, right? In one you added, let's say, this much orange squash, in the other one this much, and the third one this much, and then same amount of water was added and you stirred the solution well with the help of a glass rod or a spoon, right? Now if I say 1, 2 and 3, right? Now the first one has this much orange squash, the second one has more amount, and third one has the largest amount. If I compare 1 and 2, I'll say one is dilute because it has less of orange squash as compared to second. So this is concentrated. But now if I compare 2 and 3, this one becomes dilute in comparison to this one now, which is concentrated. So this qualitative way of expressing concentration can lead to confusion, and therefore we want exactly how much solute or solvent is present in a solution or making up a solution, and that is called quantitative way of expressing concentration. And we are going to concentrate on this particular part, right? So let's move further. So my dear students, these 7 ways are given in your NCERT textbooks that express the concentration of a solution quantitatively, right? In today's class, we are going to do this mass percentage, volume percentage, and mass by volume percentage. But before this, let me tell you the most important way of expressing concentration. You have to have these 3 on your tips when you are solving numericals of this chapter, as well as for your practicals also. Mole fraction is very, very important. I'm not saying because you'll have a direct question for mole fraction, but the concept that you learn from mole fraction or the formula that you learn here will be utilized further down in the chapter, and you will see that. Similarly, molality. When you study colligative property, we are going to study in all the colligative properties this term called as molality. So all these ways of expressing concentration are important, especially mole fraction, molarity, and molality, right? It doesn't mean that mass percentage, volume percentage, mass by volume percentage is not important. Somewhere in few numericals, it will be given that this has this much percentage by mass of solute, right? Calculate molarity or calculate mole fraction and so on. So you might not get a standalone question from these 4 topics, but this can be used for solving the numerical further, right? So begin with mass percentage, volume percentage, and mass by volume percentage in today's class, and we'll wind up with this, right? So let's begin with the first one, that is the mass percentage. So children, you can write with me. We begin with mass percentage, and it is represented by W by W. All right? It's also called as mass by mass percentage. Mass by mass percentage. Now, first of all, we'll do the formula. It says mass percent, I'll use a symbol this, of a component. Now, that component can be a solute or a solvent. So, you can have this for solute or you can have it for the solvent, right? We'll first do with solute, is equal to mass of solute. So, we talk about mass of solute divided by total mass of the solution. Total mass of the solution. I'm using short form for solution as this. It is percentage. Don't forget the symbol or the sign or the digit 100. So mass of solute divided by total mass of the solution. So this is mass, right? Now this is mass, mass by mass percentage. You need to only remember the formula. If at all a definition comes, you'll be able to define, right? So mass of solute divided by total mass of the solution into 100 represents mass percentage or mass by mass percentage of a solution. Now, mostly when we're dealing in laboratories, right, we'll talk about mass in grams. Okay, it can be in kilogram also, no problem. But in laboratories, we deal with smaller quantities. Basically, this mass percentage is used in industries, industrial calculations, industrial applications, right? And in the laboratory, when we are talking about, we are going to use the unit here as grams for this and gram for this into 100. For example, I say 10% glucose in water by mass. Your teacher asks you in the laboratory that prepare a 10% glucose in water, okay, by mass, right? How will you do it? Just look, here glucose is the solute. I am sure you know the formula, C6H12O6. Water is the solvent, right? If a teacher says 10% aqueous solution of glucose by mass, again, when they're saying aqueous, you should know that the solvent is going to be water. How are you going to prepare? You're going to weigh 10 gram of glucose, right? Now it says that I need to show you that the mass percentage comes as 10%. What does it mean? 10 gram of glucose, You talk about total mass of the solution. 10 gram is glucose. Now total mass of the solution has to be 100 because we are talking about percentage. It cannot be more than 100, right? So 10 gram is occupied by glucose. We require 90 grams of water so that your solution becomes 100 grams, right? So if I have 100 here, total mass of the solution into 100, right? This cancels out. Won't you have 10% glucose in water by mass? So how are you going to prepare it? You're going to take 10 gram of glucose. Let's say I'm having a beaker. I take 10 gram of glucose and I'm going to add 90 gram of water. Now you need to understand one important thing. Let me talk about this. You might think, ma'am is kidding. How can we have water in grams? We have water in ml. It's a liquid, right? Here is the catch. Now this is something you can mark as extra. It is required for numerical and it is important, right? Now what is density of water? Density is equal to mass upon volume, right? If I take density, I'm talking about the units, mass in grams, volume in ml. So I can have this as a unit of density. That density represented by D or rho has a unit gram per ml, right? Now what is the density of water? Density of water is equal to 1 gram per ml, right? So if density is 1, let me substitute this value here. Density is 1, mass is expressed in gram and volume is expressed in ml, right? I'm writing here as mass and here as volume. Can I say mass in gram is equal to volume in ml? And therefore 90 gram of water means nothing but 90 ml of water. It's true for water because the density of water is 1, but it is not true for all the solvents. The density will vary and therefore their mass, and if you want to convert it into volume, will vary. Remember this point because in some of the numericals you're going to use this. They will say, let's say 1000 gram of water. So you should know 1000 gram means what? You have 1000 ml of water, which is equal to 1 liter of water, right? So don't forget this or put it as extra, right? It is a simple concept, but it is important if you are doing some of the numericals, which we are going to do in subsequent videos. So this is how we prepare 10 gram of glucose in water by mass. So what exactly, let's quickly revise. What is mass percentage? Mass of solute, if you're talking about mass percentage of solvent, so mass of solvent divided by total mass of the solution into 100. So this was all about expressing concentration of solution in terms of mass percentage, right? We move on to the next method. So the next way of expressing concentration is as volume percentage, right? So if you know mass percentage, you don't have to cram volume percentage or the next one which I'm going to discuss, mass by volume percentage, right? You need to understand here we are going to talk in terms of volume, milliliters, liters. Basically it goes with liquid solutions. So what is the formula? First of all, it is going to be represented as V by V, okay, volume by volume. So you can also call it as volume by volume percentage, right? So let's talk about the formula. We'll talk about volume percentage of component, let's say solute. Now there we talked about mass of the solute in mass percentage. See, we have done this just now. We talked about mass, right? Now we're going to talk about in terms of volume. So this is going to be volume of solute or solvent, whichever component talking about. Volume of solute divided by total volume of the solution. There it was total amount of the solution or total mass of the solution. Here we talk about total volume of the solution. And since we are talking in terms of percentage, don't forget to multiply it by 100. Fine. Okay. So this is volume percentage of solute. If you want volume percentage of solvent, same way, volume of solvent divided by total volume of solution into 100. Let's again take an example. They say, let's say 10% ethanol in water by volume. Okay. How are you going to prepare this now? This is a liquid, this is a liquid, right? So we need 10 ml of ethanol. Fine, C2H5OH, that's a formula of ethanol, divided by total volume of the solution. So it has to be, total means 10 plus 90, it becomes 100 into 100. This becomes 10%. So this is correct. Now how are we going to make it in the laboratory? How do we do that? We are going to have, let's say again, a beaker. We're going to add 10 ml of alcohol, right? Your beaker will have a marking of, let's say, 100 ml. You are going to add water till this marking becomes 100, right? So you're going to add water from here. We are adding water to make the final solution 100, right? This is how we are going to prepare 10% ethanol in water by volume in your laboratories. So this is all about expressing concentration of a solution in terms of volume by volume percentage. We move on to the next way of expressing concentration, and that is mass by volume percentage. I'm sure now you know how to express concentration in terms of mass by volume. One of them has to be amount and the other has to be the volume, right? How we do that? Let's represent it by W by V, right? So if I have to find out mass by volume percentage of solute, right? This is going to be mass of solute, but now it's mass by volume, so it has to be volume of solution. Again, it's a percentage, don't forget to multiply it by 100. So this mass, let's say we are representing in grams, this in ml. So mass of solute divided by volume of solution into 100. So this is how we represent the concentration of a solution in terms of mass by volume percentage, right? We basically have no questions from here in your NCERT in-text or exercise. There is no question from mass by volume percentage. But these are important as far as your practicals are concerned, when your teacher might ask you to prepare a particular solution of some concentration, mass by mass or mass by volume or volume by volume. So to revise today's topic, let us take up questions from NCERT. NCERT has 2 questions, and both the question, if you look, are from mass percentage. This is in-text question and this is exercise question, where they're asked define the following terms. Mole fraction we have not done yet, molality we have not done, mass percentage. So the 3 ways of expressing concentration which we have done today, the most important seems to be your mass percentage. So let's take up the first question. It says calculate the mass percentage of benzene. Now this is the molecular formula of benzene, and this is how we draw the structure also. We're going to do that in organic. And carbon tetrachloride, CCl4. If 22 gram of benzene is dissolved in 122 gram of carbon tetrachloride. So first of all, let's locate which is the solvent and which is the solute. Now benzene is given as 22 grams, whereas carbon tetrachloride is 122 gram. So more amount of carbon tetrachloride, we take it as solvent. Fine, and we take benzene as the solute. Right, so it says calculate the mass percentage of both benzene as well as carbon tetrachloride. So you have to calculate mass percentage of benzene is equal to question mark, and mass percentage of CCl4, even that is a question mark. So from here we know that we have to use the formula of mass percentage. Mass percentage of benzene as per the formula is equal to mass of benzene, right? Obviously it's given in grams, divided by total mass of the solution. Total mass of the solution. Do not forget to multiply by 100. Most of students do that, they forget. Now let's see, mass of benzene is given as how much? 22. Mass of solution means mass of solute plus mass of solvent. Now mass of solute is 22, mass of solvent given is 122. So if you add them, total is 144 grams. So 22 by 144 into 100. Solve this and you get the answer. And don't forget to put the percentage sign. So mass percentage of benzene is this much. Now you have to also calculate the mass percentage of CCl4. There are two ways. Either you use the same formula, instead of benzene you are going to make it CCl4. So what will happen? You will have 122 mass of CCl4 divided by total mass of solution into 100. Right? You can do this. Or let's say your answer comes as X. Okay. Now mass percentage means it cannot be more than 100. So you know the mass percentage of benzene, right? Let's say X. So what about the mass percentage of CCl4? Percentage means 100. So 100 minus X percentage will be the mass percentage of CCl4. You can do it any way you want to. Obviously, you should follow the second method for ease and for faster calculations, right? Calculate mass percentage of benzene and then subtract it from 100 and you get mass percentage of CCl4, right? Let's move on to the next question, that is define the following terms mass percentage. You can write down the formula that mass percentage of a component is equal to mass of that component divided by total mass of the solution into 100. With this, I come to the end of this video. In my next video, we are going to continue with different ways of expressing concentration of solution. So stay tuned to my channel. If in case you have not subscribed my channel, do please subscribe and share this content with learners who might benefit. Until we meet next, take care and stay bonded, my dear learners. Thank you.